For the given polynomial, we know that 1 is a 0. We need to find all the remaining zeros. First of all, since it's an x to the 4th, that means there's 4 zeros altogether. So we know 1 is one of those zeros, which means we can divide it off to find the remaining zeros. So let's do synthetic division with a 1. So whatever we're left over after we do synthetic division will tell us we'll have the remaining 3 zeros in it. So 2, negative 15, the remainder of 0 just means, yes, it is a 0, so we expected that. So now we need to find the remaining 3 zeros that are in this remaining polynomial, the 2x cubed minus 15x squared minus 11x plus 24. Factoring by grouping does not work in this case. So let's just try synthetic division again. Maybe 1 will work again. Worked once, it might work again. And it does. So negative 1 is actually a 0 twice, which means it has a multiplicity of 2. And we need to find our remaining factors from, or our remaining zeros from 2x squared minus 13x minus 24. So we can do quadratic formula or factoring to figure out the remaining 2 zeros. We don't need to do synthetic division again and again and again. So to factor this, 2 times 24 is negative 48. We need to come up with 2 numbers that multiply to be negative 48 and add to be negative 13 to factor this. 16 times 3 is 48, and negative 16 plus 3 is negative 13. If you couldn't come up with those, just do quadratic formula. That would work out. So since we were doing the bottoms up trick, 2 in the front, we need to divide by 2. So that reduces to x minus 8. This does not reduce, so it's 2x plus 3. Tee it up, you get x equals 8. And x equals negative 3 over 2. So to list all of our zeros, we got 1 as a 0 2 times, negative 3 over 2, and 8. So negative 3 over 2, 1 with a multiplicity of 2, and 8.